Hello everyone, welcome to another stream. So last stream, let's do a quick recap. We were improving the sky performance. So the problem is the sky was taking milliseconds to generate. Oh crap, what's this? No. It's taking like 18 milliseconds to generate the pre-filter map, it was called, the specular reflection map basically. So yeah, that was taking a long. So effectively, we wanted to split this up over multiple frames basically and generate it over maybe, let's say, 16 frames. So that's what we've been doing last stream, and we got most of the way there. We're just on the last one, and supposedly I messed something up, so I got to go back in and fix that. No worries. So today we're going to be wrapping up on that, improving the sky performance by rendering it over multiple frames. So it means when we change the time of day, we can't change it too quickly, because if not, we will see it sort of jumping all over the place, basically. So it's got to be done very slowly. So we want to change it from one time of day to another. It's got to smoothly animate over. If not, it's going to look weird. And we'll do some night sky rendering as well, as the title says, because currently our screen is pitch black. We want to try and get some sort of stars in the sky, something like this, and maybe some sort of nebula, maybe. So we'll take some inspiration from these shaders here and come up with something. Cool. Yeah, quick prayer. Father Lord, thank you for this day. We bless your holy name. We give you all the praise and honor for our lives. Thank you, Lord, for doing your good work in us and helping us sanctify ourselves and pray and seek your face every day. Thank you for providing the breath in our lungs and all the food on our table. Not everyone has these benefits. Not everyone has this stability in their life. We thank you for that. And Lord, I just pray that every soul that comes by the stream today, you keep drawing them in, Father, and keep revealing yourself more to them and reveal them Jesus Christ. He is the way, the truth, and the life. The only way to the Father is through him. And I pray they see and understand that through the blood, their sins are forgiven. It's not by their own works. It's not by their own good deeds, which look like filthy rags. It's by the work that Jesus did, the perfected work that Jesus had done. Thank you, Lord. In Jesus' name we pray. Amen. Right. Let's go. So today, why is it crashing? Yeah, so we got halfway through a change, I think, last stream, but maybe I undid some code before I saved it, or before I closed it properly, and then saved it in a weird state. Right. Oh yeah. Oh right, yeah. Okay. Yeah. All right. So we basically needed to double buffer some images, so I just made two of the irradiance and two of the reflection. The irradiance map is used to do the diffuse irradiance, basically. So the ambient lighting on a mesh, we would look up in the sky irradiance, so it's pre-computed ambient lighting basically. Now what we probably want to do is have just one of these images, and we'll call it the IBL, so image-based lighting bake image. And rather than having double buffering two of these, we'll just have one bake image. We render to the bake image, then copy it to the destination when it's done and ready, rather than doing it over a series of frames, and we'll watch it flicker whilst it's trying to build it, basically. That's how it was getting flickering lighting by doing that before. So that's the way we're going to do it. So the way it's going to be... Right, I gotta sort this out. Yeah, so the reflection map, irradiance map. Now we want to do one more. Call it the bake. IBL, image based line. Bake. Image based line, bake. Lovely. Okay, so when we need to change the resolution of the sky, so we do sky shading if the qualities change, stuff like this, or the first iteration into this, or the first call into this function, we're going to reinitialize all the images to their proper sizing. So we would like to have the image baseline bake image to be the size of the sky map, basically. Cool. Now, so there's different phases through the sky generation. It's one of these per frame. We just go to the next one. So it takes 4 frames to generate the sky. It generates different edges of the sky, different corners of the sky map, and then yeah, it does that. Yeah. Yeah, I wonder if we should do that to the IBL bake or the yeah, rather than IBL bake image, we should maybe just call it the bake image. We should always render to the bake image and then copy it over, I think. Yep. So even when we're doing the sky, guess we'll call it I. So it's G, GFX, VK, SkyGen. So it'd be 0 to 3 inclusively. And so that would be I mod I divide by 2. No, wait. Yeah, that's right. Oh, then multiplied by the sky dims. Something like that. Let's just put the brackets so it's explicit. Okay, so now we want to make sure when we shade, we're going to shade directly to the bake image rather than the image, sky image itself. And then after, if it's the last one, we want to do an image copy. Or copy image it's called. Yeah, one of these. So, well, that reminds me, with the bake image that we've just made, the number of MIP levels that we need is only 1. right, one of them. So it's just a big enough texture just to do whatever we want on it. So rendering for either the sky map itself, the irradiance map, or the reflection map that we do behind the scenes, and then we simply copy it to the destination when it's done. So after the third one is done, we do a copy. That will probably take around 0.1 milliseconds on this card from my previous tests, around 2K resolution. So it's not free, but it's, you know, yeah, it helps save having, you know, we could basically just swap the resource ID around. That's the other way of doing it, is we swap the resource ID. And then you don't have to do the copy anymore. But then you'd have to have full MIP levels and stuff like that on. Yeah, it doesn't work. So the destination image will be the sky image. The source will be sky bake. One MIP level. Mark it explicit in there. We do the copy and then we do a down sample. So we've copied into the first MIP level and then we down sample that fully there. So this as well is kind of very cheap. This, like, is super cheap. Is the AMD single pass down sampler. It's quicker than it'll be quicker than copying the full resolution texture because it's working on half and half and half sizes, so it's very, very quick. Cool. So that's the sky one changed to this new thing where we use this bake image. The irradiance takes 9 steps. So we used to have in the previous stream we made 2 images that we would switch between basically, and then commit it at the end. So build one behind the scenes and then commit it. We don't do that anymore. This time we're doing the bake. The bake image. So that would be destination would be this guy. Yeah. GGIF X BK Sky Bake. So with the Sky Bake image, we'll render to that. The irradiance map render is going to store on the first step. On the first step, it's going to store but not read, and it's going to do a store rather than an additive blend, if you get what I mean, right? Whereas, yeah, so if a step is non-zero, it reads the pixel and then accumulates it basically and stores it back out. So we do the hemisphere in 8 or 9 steps. It's 9 steps. And then we render that out. So it's done over 9 frames there. Then on the last one, we want to do another image copy. So we get this. We went from the bake image to the irradiance image ID, like so. Cool. Nice. Then the next one is this reflection MIPS. This is where we got to. This one we actually got to adjust the shader for. So the thing is about this one is the reflection image is quite complicated. Like it was taking it took a lot of frames, and we probably need to run it again just to understand how we need to split it up. But I've got my, we want to know how many steps to split it up into, but I have an idea of how we can do it. So So I think we'll just render directly into the reflection image. Okay, let's try that out. Now hopefully that's going to work. All right, we'll crash. So we need to put some transfer flag, image usage flag on, because we missed that one, so this one here. So when we make our images now, so the irradiance image needs to use that. Sky image and the reflection map image. The bake image needs to have the source, because it's going to be where it's coming from. Ah, Vulkan. There we go. Yeah, so it's cool. It's working. Now, we've got to look at, there's a, oh yeah, that was it. Yeah, so I'm look at the performance. Wrong button. I need to swap those around the other way. F8 should be, F9 should be the, yeah, I'll do that. Anyways, so we're looking around here. I'm going to turn on the SkyGen override so we can see the performance of these things. So 14 is the, 15? Yeah, okay. So it's around 11 milliseconds. And then 6 for the rest. So we want, on average, we want to be around a millisecond. We don't really want to go over a millisecond. Looks like I need to split that one up more then. Anyway, we'll look at that in a bit. So right, so around, yeah, 11 milliseconds. So for the reflection, cost 11 mil. So we need to break this up into like 11 steps, basically. Because we tried changing some of the other parameters and it just took us, yeah, so, but this does all the rest of the MIP levels. And we probably don't need to break those up into 11 steps, probably just one step for each MIP level, maybe. And maybe group some of them together into a single frame. So effectively what we want is to do zero 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 one 4 5 6 7 8 9 10 11, yeah? Wait. 11 steps, you want that? Cool. Now, I don't know if I want to put another underscore, to be honest. something like that. Now, okay. So we've got to somehow call this in 11 parts. So we're going to add some sort of step parameter in there. So we've got to remember that at the last one of these, so if ggfx vk sky generation, if it's equal to the last one, we would basically want to do an image copy from the bake image to the reflection image, and they'll only be for the first MIP level. Well, we should already know that it should work like that anyway. Yeah. Now, yes, so we would like to render. We don't care about the number of MIPS in this section. The sky bake image. Cool. Lovely. So if we try. Now we've just got to go into the reflection map generation and find a way to split this up. So I'm not sure if you remember how this one works, but let's just go to learn OpenGL. Effectively, what we're generating is a image-based light and specular IBL. So it's they call it a pre-filter map, I just call it a reflection map. So if we have the sky map, it looks something like this, but outdoors. Then, well, this one's a cube map. My one's a equal rectangular. There's just one texture rather than 6 textures, right? For each face of a cube. It's just a different projection. So you then go down each MIP level and it kind of looks a bit more frosted, if you will, a bit more blurrier. But the way it does it via actually sampling in a cone. So when you take a normal that looks at a certain pixel on a environment map, it's essentially sampling that same area but on the sky map and producing this sort of like cone. And the rougher it is, the wider the cone is, and the wider the sample is, and then stores the result in the pixel where it's pointing at in the reflection map. So this means when you hit a surface and you get the reflection vector, you can just look up the result in the sky map and saved in this very, very expensive computation. So it was costing 80 milliseconds, and then I reduced the sample count to 256. And then it brought it down to 11 milliseconds. Right, so that's acceptable, but we've got to break it up into 11 parts, because if not, we can't make it take a series of frames. So what we've got, so effectively what we have to do is similar to the irradiance one. So the first thing we need to do is go into the shared header, and we have to change it to read write, and we have to sort that out there. Good. Then we have to go into the irradiance and copy what this does here. So there's a reflection color. And essentially we want to accumulate the result. Now here's the thing. Because the weight is, we've got to be very careful here. So the weight is the n.l accumulated. Now, what we should probably do is divide by the weight. set the alpha to total weight. So if the step is equal to the steps count, take 1. Then what we want to store in there is 1. Else we want to store the total weight in there, such that we can reconstruct the original value, something like that. Hang on a minute. It's got to be perfect. So we'll store 1 in there at the end, else we're going to store in there the total weight. So the reason why we want to store the total weight in there is because when we're trying to merge a previous sum, previous iterations, like when we do this all in one iteration, we're doing this for loop in one go, you're going to get the total weight is just going to be n.l accumulated, and the reflection color is just going to be color times n.l. But because we're storing out into a float 16 image, we can't really trust storing that reflection color back out into the texture and not losing precision. So what we want to do is always divide it by the weight, right? Always divide it by the weight when we are storing it back out to the texture, and store the weight in there such that we can compute. Is that right? Yeah. So old. So we load the old one or existing. And we do existing and then we want to make sure total weight plus equals existing dot a, something like that. I think that's right. So we want to essentially restore it back to where it was before and accumulate the reflection color, and then accumulate the weight, pack it back down, and then store the weight back out to the texture until the final step. And then we'll just put 1 in the alpha. That's how we'll do it. Okay. So now we just got to do the thing of splitting this up. Right, so there's a certain step count. Pass this in. So reflection render. We want this sort of step thing here. That'd be cool. Oh, so effectively we have 256 samples. Now, this might get unrolled as well, actually, known shaders. This typically gets unrolled and makes this super long, and yes, maybe this will help with performance as well here, I guess. I don't know. So what we want to do is essentially work out the number of iterations. Now I've got to be careful. You want to have your start and end basically. So the start, that is going to be equal to the step we want to work out the step. Did we call it steps? We didn't call it step stride. What do we call it in the previous one? Step. Oh, phi step, I called it. Right, so we want to basically work out the step stride, I call it. So that would be the sample count divided by the number of steps. But that's not going to be good because that's integer. So it's going to do a truncation on the divide, isn't it? So we got to be careful about that. But let's just write the logic. We can fix it. I think I've got to do divided round up. We'll see. So yeah, I think I've got to just do a divide round up. Anyway, we'll look at that. So step times step stride. Then the end is me step plus 1 times step stride. Then we want a minute with sample count. So start and end, like so. Now, this is going to be a problem because it's an integer, not a float. So essentially, if it's not perfect division, then it's not going to work well. So you want to make sure your stride is a rounded up, isn't it? Something like this. So divide round up. Perfect. Yes, I think this is all we need to do basically to make this work. So if we pass in divide by 1, that obviously just be 256 still. And then you would have 0 times by 1, 1 times stride. Yeah, stride will be, 256. Yeah, sorry, 0 times 256, that'd be 0. Then 1 times 256, min 256. Yeah, good. Lovely. So this can work for a single iteration, but also many iterations, which is what we want. Amazing. So let's try and plug this in now. So essentially, we've got MIP0. This one needs to take 11 steps to fit into the 1 millisecond budget. So hopefully this will still be 1 millisecond. So, why are you complaining? Yeah, you want to be a read write. Okay, cool. So your steps count is going to be 11. Then, I guess we could do this to make it more explicit, like what 11 means. It's going to be this and including, isn't it? Then the step that we're on is going to be effectively GFX SkyGen minus this one here. Yeah, so that would be the current step that we're on. Lovely. Then the final one just does a copy. Cool. And then we want to keep iterating to the next one like so. Now, the problem. So we probably want to make MIP1 also take a few iterations as well, to be honest. So if MIP1 was if MIP0 was taking 11 milliseconds, the rest of them was taking like 6. So we do some basic maths, right? 11 milliseconds divided by 4, because it's 4 times less pixels, that will get you at around 3 milliseconds, right? Something like that. Yeah. So yeah, that works out then. So because it's 3 milliseconds, we need to split MIP1 into 3 different things. And then the other ones should all fit under a millisecond, potentially. So we could, well, yeah, would need MIP2 to be on it by itself, and then MIP, the rest of them can go together in the final one. Yeah. So let's get those put out. So that would be this as a 1, and then we want to have MIP2 to be by itself, and then we have an etc just for the rest of them. That's a lot of frames to get the reflection map done, but there we go. So I wonder if there's a way we can make this work, you know? Maybe I think we can just make a function for this, right? Yeah, I think it's time for a function. It's going to be repeated in like a few places, but we're just going to do it, I think. Right, so we'll call it excuse me, reflection. The reflection map. So it's going to take some input parameters, we'll just figure those ones out. So we want to know like a number of steps, and like, so step, how many steps, pass those right in. This is step, how many steps, and then we would also like to know, so we kind of want to know what MIP level you want as well. So what MIP is this? So so we need to work out this roughness parameter. So something like MIPS count. But to be honest, you can get the MIPS count anyway automatically by doing something like this. Cool. Then we also need to work out your dimensions based on your MIP. So there's a thing for that. It's called GPU VK MIP dims. You pass in the base dims and the MIP level, and voila. Easy peasy. So what else do we need to change? I think that was basically it. Maybe these dimensions. Oh yeah, you want to make sure yeah. So when we write it back out, that's it. Right, that's good. That's cool. So when we're on the final one, so we call this the step plus 1 is equal to steps count. So the final step. We want to put it back in the reflection map, and we want to specifically put it at the MIP level of sorry, the base MIP level, what's it called? MIP destination mip is equal to mip. And it should get the resolution. It should automatically work out the resolution and do that, which would be cool. So from the bake image, it'll just take the corner basically that's rendered into, yep. Nice. That's really cool. So now we've got a nice reusable function. We can use it in a few different places. So effectively, the mip we're doing is 0. I guess we can just write these out here. So step and steps count. So it's readable when we read the code back and we're not guessing what the parameters are. So mip is 0 in this case. Step was these guys, right? Cool. So steps count, blah, blah, blah. Lovely. So we just do that and we increment by 1. Now we've got a new one which does up to this. So for mip1, yep, it's a very similar thing. So for mip1, we're going to yeah, I think it's that. So mip1 needs to take 3 steps because that's going to take around 3 milliseconds. So we break it into 3. We might have to break into another one though, we'll see. And then we'll want the final one, well, second to last one, which is mip2. So mip2, we just need one, we're on step 0, there's 1 step, we pass that in, very good. Then the rest of them need to be done here. So for this we need the number of mip levels, and then we need to do a for loop from 3 to the rest of them, and then we're going to call this with a step count of 1. And then mip, yeah, that's what we want. So do the rest of them in one pass, basically, rendering out to the same image, and then do a copy at the end. So hopefully that will work. Right, what could go wrong, eh? We just changed a lot of code. Let's see what happens. Right, got compile error. So line 70. Hey there, Oshai, welcome. How are you doing? Line 70. Oh, okay. There's a bool. A Boolean type? What are you talking about? Oh, okay, it's just stupid. Because GLSL wants it to be an explicit Boolean type for it to work. Your name is great and worthy to... Oh man, I hate GLSL so much. Such a terrible language. Lovely. Right, let's see if this works. So let's fix the... Hey there, host 48, how you doing? Welcome, welcome. So let's fix the sun direction. Yeah, so we do see things catch up over time. Hmm. Looks a bit fishy to me in some regard. So here's the reflection. Right, clearly there's a problemo with the copying. Look at that. Does look nice. So clearly we're not copying into the MIP levels right, and it's causing a big problemo. What's the... Right, let's look at the bake image. Let's go through these steps. Yes, it is accumulating into the corner there. That's nice. $15, wasn't it? That's the first one. So the first one should just be storing in the image. But I don't see that happening. Is it not using the bake image? Your name is great. It is. Hmm. Hey, Xcoding, welcome, sir. Um, yeah. I'm looking at the bake image, right? So the bake image, if we look at the profiler. Let's pause that. Yeah, the reflection render there is 0.12. That's really cheap. Did it really get made super cheap because we got rid of the for loop? Is that true? No, it can't. Sorry, we didn't get rid of the for loop. We got rid of the unrolling for loop and made it not unroll anymore because it wasn't a constant. But I don't think that's the case. We're not seeing it change the full image. So my suspicion is that and why is so the radius map render is over a millisecond and right, the first reflection one is like super cheap. Why? Right, I bet you it's not I don't bet you, but I reckon then maybe it's not even running the for loop and doing anything maybe. Your name is great. Right, so what we're going to do is try this out. Yeah, so it's output black. So it means it is... Oh, there we go. Ah, so it's doing it. So what is step then? Can we see what step is? Oh, that's not going to compile, is it? Oh, PC step. Right, is that looking kind of grey? It is. Oh, it's because it's white. So that means step is non-zero. In this particular case here, step is non-zero. Step is 0 right there, okay? So if we put reflection color, cool, we get the full image there. Now, if we go back, why is it getting rid of that now? It wasn't getting rid of it before. You know what? My shaders weren't recompiled probably. Probably what it was. Maybe the shaders all weren't recompiled. Can we? Right. I don't know what's going on with the build system, but it's got to that time where we just delete the build directory. Here we go. We go again. Whew. No biggie, it doesn't take long to build stuff. Right. Let's have a look. Yes, that reflection image looks kind of good. I like that. What we're going to do though is fix the time of day. It is kind of flickering though. Let's just inspect the images first. We can do all the flickering as we go. So if we go down the MIP chain, let's bring the brightness up a bit. It's wider and wider sample counts here. We could probably do with a, yeah, for these ones we could probably do with a higher sample rate, I think, because the cone would be very wide, but it's okay maybe. Yeah, we'll probably do a wider anyway. So what could we? Yeah, could we test that out? Kind of be nice. Yeah, let's look at the other ones just quickly. So this is the irradiance map. That's done. That looks nice. That looks fine. Obviously the sky image. Here's the sky image. We go down the MIP levels. Looks good to me. Now, those were all the ones that were generating basically. The bake image can look like rubbish because, you know, it shows this is the reflection map being generated progressively down to the lower one, right? So that's fine. The way it's supposed to look. Amazing. Now, what I want to test is the performance now. So bring up the settings. If we turn on, so 15 was when the reflection started, wasn't it? Right, still 2 milliseconds, damn it. No, I thought it was enough. And the last one, yeah, that's not good. It needs to take more frames to converge then. Okay. So let's take a look at some of these numbers. So sky lookup table's fine. The irradiance map probably needs another split. Right, let's start with the irradiance map. Let's move that one around quick. That was about 1.3 milliseconds. Let's see what that is. Very close to being done, which is great, and we can move on to the sky, the nighttime sky rendering. So let's introduce another one and see if it does improve performance, but we had to introduce one to get I thought another one just would have been enough, so maybe there's something else that's going on which would not be good. So there we go, we've upped it to a 10th step. Oh crap. Yep. Let's make that work better. So a 10th step, let's try that. So if we bring up the settings, bring up the profiler, fix the time of day, and now we try radiance. Right, it is around 1 millisecond now. Yeah, that is 1 millisecond, that's really good. Roughly. Some of them are 1.3 still, I think. But it's better now. Alright, so it looks like we need to introduce more for the... Your name is great and worthy to be praised. Yeah, I think we need to introduce many more steps for the first one, which kind of sucks. The other thing I wanted to test out quickly is like, if we change the yeah, we changed the, what was it? Yes, the reflection map, the lower MIP. We can see it's kind of looking a bit specky as you know, it's aliased, I guess, you know what I mean? It's not smooth. So I reckon if we bump up the, now we can see what this looks like, right? If we bump up the number of samples in the, so the cone is too wide. So the number of samples is too, I think as the cone gets wider, this needs to also get more intense. So let's change that. I think that's worked out better. It's hard to tell now, isn't it? Let's keep them up. Yeah, okay, so we clearly saw that change. I didn't even have to, yeah, does on shader reload as well, which is cool. But, right. Interesting. So, we're at 512, is that right? Yeah, really, we could do that. But the problem is 1024 is very expensive, right? It's 4 times as expensive. So I don't think we're going to be able to cope with that. Right, so MIP 0, what's the difference that it makes? We don't see it, right? So we shouldn't even do it for MIP 0, right? So for MIP... Oh, interesting. For MIP 1, there's a clear difference. For MIP 0, no. So MIP 0 can live at 256, which would be great. But then MIP 1 will have to be 1024. And I wonder if this is because of the Wait a minute. How big is the cone for MIP 0? If first MIP 6, tweak to avoid. Yeah, so that's a min roughness basically. Yeah. Right, so MIP 2. Obviously, there's a clear difference. Okay, so... Yeah. We're going to have to pass in a sample count parameter then. That's okay. Right, what's the performance look like? Hey there, Rafi. How you doing, sir? Welcome, welcome. Yeah, so I feel like we're just going to be adding a whole bunch of these now. And I don't know. It's just a load of switch case stuff, but maybe it's fine. Yeah, we'll just have one variable rather than many, I think. What we could probably do is do something like sky. Right, then you won't have to keep defining one by one. Then you kind of do to go into the, yeah. Yeah, I think C, what is it called? C, or the GNU version of C has those range operators for case statements. So I guess this is where that'd be a benefit there, but I guess you just switch to an if statement after that, really. Yeah, I guess we'll just... Let's go all the way up to 16. Your name is great. Alright, I want to get to this nighttime shading in a minute. Let's go here. So we want to do the reflection map. The number of samples, right? That's another one. Like a samples count. So we want that to also be another parameter. Shared. So samples count. So for some reason 256 looks nice, but for the rest of them, yeah, so on MIP0 256 looks nice, but for the rest of them, 1024, and that's going to be far more expensive, 4 times more expensive. So we're probably going to need more. Yeah, so thinking about it, what was it again? This one, probably going to need more as well. Hang on a minute. So let's just test this out. Oh, we didn't change the shader. PC samples count. Yep. Cool. Yeah. Okay, so let's take a look. You know what? I wanted to change that thing, didn't I? The profiler is bound to like the F8 key or something like that. I'm gonna change it. To F8. So F9, F8. Because I keep pressing the wrong way around, basically. So I don't know where that muscle memory is coming from, but I think F8's my texture viewer now. Yep. F9's the profiler. Lovely. Right, those numbers are looking a lot better. Just have a look though. This is what we should expect to see, right? As the time of day changes, the part of the sky map is, yeah, it's generating a slightly different part of the sky map. But yeah, it sometimes generates the actual sky map or the irradiance map or the reflection map. So now we're going to go through the different generation steps and see what the performance is like. So radiance is around 1 there. That's okay. You could probably do with one more step, to be honest, to bring that down. So one more radiance map step. We need more reflection map steps. Those are expensive. I don't even know what 32 is, to be honest. So if we've got 16. Yeah, so we've got 16. So that would have been the MIP1. Oh, 8 milliseconds to get down. Yeah, so it looks like we probably need another few of these. Quite a few of these. I'm going to go up to 24. There we go, 24 different ones. And these should probably have, well, you got 8, right? So if you double it, that's half. So that 6 would be half. Right. So yeah, you want to do like half and it would be 6, and half and again would be another 6, that'd be 12. That'd be then a 2. Then you got it, yeah, so it's another 24 basically. So many of these things. So 24 frames for MIP1. And then yeah, so we probably want to add one more irradiance. There's 10 there. This is a big enum. And this goes up to... We should probably just, code these in basically as how many sub-steps. Because... kind of ridiculous. Yeah, we'll do sub-steps. It's getting too many. So... define SkyGen sky steps for irradiance is going to have 12 maybe. Then reflection MIP0 is going to have 24. MIP1 is going to have 24 as well. So that makes sense because if MIP1 needs 4 times as many samples but is 4 times less in size, so that it cancels each other out basically. And then MIP2 will need 4 times less than that because it's working at the same sample rate but less resolution. So that will be so 4 divided is at 6, isn't it? Yep. And then 3 would need 4 times less than that. So we could probably make it go down. It probably needs 2 steps, right? And then the rest can fit, the etc. can fit into 1 step, basically. Oh. That was... Right, so we can at least bring this down to something sensible now, rather than just one big silly num. Then etc. will just be 1. Cool. So let's go and just adjust the code a bit. And then we can do some night sky rendering. So we want to have another thing called SkyGen step, we'll call it. So effectively that's going to start at 0. Then basically every time you, I don't know, yeah. So SkyGen I. So if step we up the step if step equals the number of steps, then we want to set step back to 0. Step back to 0 whilst also upping the gen. Something like that. Cool. So I guess we'll do a +1 for there. Now it's a similar story for irradiance. We're going to have a sort of like a step and the number of steps is just going to be the global constant here. Hey there, Zimmer. Hey there, Zimmerdam. Welcome, sir. How you doing? Welcome to stream. Yeah, so if the steps is finished, then reset the step count, advance the next SkyGen step, which is MIP 0. Cool. So this one has a series of steps as well, doesn't it? Yeah, I think we would like this. So we keep having to do this all the time. No, I think it's fun. So with the sky steps, we want irradiance steps. Yep. Then this wants to be reflection MIP 0 steps. So it's the number of steps there. Cool. That's looking nice. Right, so I think this is basically the same. Just... So I'm copy and pasting, which is going to probably introduce problems, so I've got to be careful. So MIP 1. MIP 1. The sample count is 1024. And then MIP 1. Yep. And then we want to do a MIP 2 as well, and there's a MIP 3 as well. Just double check that. So 2, MIP 2, 1024 for number of samples, advance. Yep. Now there is a MIP 3. Yeah, that's good. Then there's an etc., which goes from 4 and beyond. Okay. This looks really good. This is far better now. And the debug should still work. Kind of. It's just when it's changed. Right, let's read some of this code back just quick. So if the quality settings change, work out these dims basically, and then reinitialize all the textures like the sky lookup table, the sky image, and the radiance and reflection, and the bake image as well. We would like to also set the step back to 0 as well. Start on the lookup table, regen. Now, if the SkyGen is equal to none, but the sun direction has changed, we want to regenerate the sky again, so we should probably set the step back to 0 as well, just in case. And then if you have this SkyGen override, what we probably want to say is, if your SkyGen override and your SkyGen override is not equal to the current SkyGen, then set it, but also set the step back to 0. Yeah, so when we have the debug override slider and we move it, it sets the steps back to 0, so you won't be halfway through some steps when you change it. So that should not produce any bugs there. Then the reload shaders. I do have that case in there. That's great. Every time I reload shaders, it back to the lookup table. Cool. That's really good. I like that. So So what we could do is kind of delete a lot of this code. We could, well, not really delete, but yeah, we could. Yeah, the advance. Yeah, let's do this because it'd be better. So you want to basically get the number of steps. So the steps count is just going to be set to 1. So all this stuff where it ticks it to the next one, we move out. So essentially you want something like this down at the bottom. So what we're basically saying is, right, advance the step. If the step is equal to steps count, then set the step back to 0 and advance to the next. Now each case statement has the ability to set a different steps count and avoid it from ticking too fast. So that avoids... Now the issue is though, is you'd have to do a plus... You have the opportunity to move some of this into a second switch statement maybe, but that might be a bit annoying. So I think we'll just do another +1 here. I think so. Just makes it a little bit less error prone, I guess, and a little bit neater for stuff like this, because you don't need the if statement here anymore. Very error prone if we don't do this properly. Cool, and then the steps count. Oh yeah, this one will just set regen to none though. So for this one, I guess we could just do a return. And then that's 0 again. So, well, when you set it to none, then the sun direction changes, then it resets it, so you shouldn't have to set that. Yep. So I think that's it. We can try it out now. This should all be at a range of 1 millisecond, hopefully. We've got our numbers right. So, right, that's all looking around a millisecond, but it does jump very far though. That does look a bit scary to me. So, let's see if we can hunt that one down. So if we manual sun direction. Right, it appears to not be wanting to stop. No. Which is a different problem. Oh. Right, so that's pretty good. We've got to bring these down a bit. Right, let's go into the settings quick. .encoder file. Let's change the range of that. So the range needs to be, I don't know, what do we have these days? Graphics internal. That was a what? Right, so there's 8 or 9 of them. Let's do 10, just in case. So now that slider's a little bit better. So we'll get back to that other bug. Sun direction fixed. Right, so if we chase down the particular gen step, Oh, they don't want to regen the... Come on. Yeah, it goes up to 10 now. That's good. Cool. So let's fix that. Right. So the irradiance map one looks good. That's under a millisecond now. Lovely. 4 is the reflection map, MIP 0. That's basically a millisecond. We can live with that. MIP 1 is, it needs more, right? It needs more steps. So that could do with probably 32 steps, not gonna lie. So up that to 32. MIP 6 needs, not MIP 6, sorry. MIP 3 is about the same time as well. MIP 2 is basically there. And wow, they're about a millisecond each for the rest of those, aren't they? That's probably because they're a very small image, so they have very long running compute units on a very small image. I didn't realize there was that many left. How many in the reflection image? Oh yeah, we still have a lot to go. Okay. So it looks like what we need to do is do one per... It's fine. This is pretty easy to work out. So MIP 1 needs to be 32 steps. MIPS 2, it was basically the same amount of time, the right amount of time. Sorry, it's about the same amount of time as MIP 1 was. So we doubling it's probably going to half, I think, isn't it? So maybe we can put it, yeah, let's do 32 divided by 4. That makes it 8. Let's try that. Yeah. Now, 3 probably needs to have... I think 3 was fine. So etc. needs to have its own number of steps. We'll sort that out. So etc. This one would like to actually have some steps, and this would be the number of MIPS, of remaining MIPS. Be MIPS count take 4. Is it up to and including, or is it starting from 4? Yeah, no, it's not including, is it? Good, good, good. So you just want to do that. So basically 4 plus G graphics VK step. That's your MIP. Something like, yep. Now, if your steps is at the end, so it's this sort of thing here. We just want to set it back to SkyGen none and return. Cool, so I think that's what we want. Ooh. Oh, something doesn't look nice. What's going on there? Does it never reach? Um. Ah. Shadowing. Shadowing. I think that was the problem. Right, that's working. So profiler. Fix sun direction. Okay, that's good. It does keep going, that's fine. Right, so they're about... Yeah, there's about 1 millisecond now. Ooh. Amazing. Yes. Right, we're done now. That is good. So I just want to quickly test one more thing before the sky. Is how does it look when we change direction? Does it look fine? Does it behave how it's supposed to, I think is the question. So if we change the game camera, so if we go to the orbit, so we basically want to fix, if we fix the phi down to 0, so it's flat against the horizon, keep spinning around, and probably increase the distance out to 32. Let's try that. Alright, so we've got a bit of a seam. That's an obvious problem. I wonder if we can fix that seam in the sky, but anyways. So we change the sun direction. Like, it's okay to take a few frames to do it, because what we should be doing is gradually changing. I'm just going to make it go automatic now. I think this is fine. It's just obviously it should be way slower. Yeah, I think it's fine. It comes across all right. Let's move closer to the balls. Wait for it to come up to the time of day. So as you can tell, it's pitch black, right? We want to sort that out. But yeah, I'm not really looking at any flickering. Cool. Lovely. I'm happy with that. What was the other thing? Yeah, this seam. Can we sort that seam out? That would be nice. That seam comes from the down sample. Sky down sample. So you need a repeat. We found this problem out in this when we did the skies. What was it? When we was doing the irradiance map, there was a dot on top, and it's because we're using a equal rectangular texture, and it repeats on the X, but it doesn't repeat on the Y. So I think the problem comes from, so we're using the single pass down sampler. What we probably want to do is on the load is we want to do a special sample. I think we can do it. This will be fun. So if we find the scene shade, there's the rectangular one of these guys. Where's one that's right next to each other? This is it. So, wait, from direction. Mm, you maybe don't need the. Yes, I think the basic idea is you get your image, but maybe you get it as a interesting. You want to get the base image ID as a texture and sample it using the equal rectangular sampler. Or equally though, you could. Yeah, but that equal rectangular sampler is not gonna. That's gonna do an actual like 2x2. Yeah, I don't get it why it's. Yeah. Yo, I have to do some research about that offline, I think. We can't fix that problem today. Let's have some fun. So we want to look at doing the sky map. So we want to put some stars in the sky. Nighttime. So we should probably fix the time of day to nighttime. And then we'll stick a moon. Your name. Yeah, so we just default it to manual sky direction mode on or whatever, right? Yeah, stick it to on by default. And we can work on. Yeah, it's about 0.52 and on. Settings. Right, so can we default to on? Now, we also want to not rotate the camera. So I need to find that code. Here, this theta thing would probably just be fixed to something else. I don't know though, maybe 0 is fine. Find out. And then we can start by putting a moon in the sky. Right, we'll just make it the opposite direction to the sun for now. We could probably do a more realistic moon thing later on. So I think we're looking the right way. So let's have some fun. And let's start by putting another sun in the sky. So sky shade. We just spent time to make the performance good for the rendering the sky over a series of frames. But now the we're going to be making it slower for this sky shade, but there we go. It's all right. So if we take the sun, the ground distance. Yeah, so the ground distance is great. I get the sun color. So the moon color, we'll call it. And it's just going to be the opposite of sun direction. And nothing. Oh, because we need to accumulate it. Right, so if I just double check we're actually doing something. Let's up the brightness. Okay, so it is compiling. So we just got the code a bit wrong. I wonder if we're looking the wrong direction. Can we swizzle? That's not very nice, is it? We'll re-put on the camera rotation. It might be because it's in the ground distance if statement. I've just busted the... Yeah. Sometimes my hotcode reload crashes, it's not the best. Alright, so rotate. Not helping out, so it's okay. So I think what's going on is that ground dist thing. So yeah, that just means it's in the sky, right? So what could be happening is that the balls are in the way. Seems sensible, actually. That could be what's going on. It's weird you see a bit of a seam. You're seeing the four corners of the sky map here. So, yeah, this is a camera angle that's worth it, actually. Why? Oh, I know why. Yes, as... Oh, that's interesting. Yeah, so we need to fix... That's really good, actually. So when we render a sky... Right, I'm glad we've found this bug. So the sun direction needs to stay still when we're trying to render the initial sky. So we want to be using the one... Where'd you get the sun direction from? Yeah, here it is. So radians. Okay, so actually... So we want to poke into the globals. What we want to poke into the globals is... So based on the manual settings, the unorm... Now the world will be located in GFX VK payload world. I think that's right. Yeah, good. So we want to make sure that the one we're uploading to the GPU is the GGFX VK sky gen sun direction. So whatever's been generated on the sky currently. Yep. So that would fix. So what would happen is it would do 4 different quarters of the sky map over 4 frames. So when we changed it, you would see that. So now if we watch the sky change, you won't see it. Yep. Cool. I'm glad we fixed that problem. That's a good one. So anyway, we're currently looking in the wrong direction to see the moon, as we could tell. So to see the moon, we need to rotate the camera 90 degrees. So that would be this one. Right. And then right, so now I've rotated. I think I rotated the wrong way. Maybe. Yes, it's pitch black, so we should be seeing the moon that we've got, but I can't see it. Right, let's go back to the sky shader. So no moon color has been added at the moment. What's the sun direction? Yep. Oh, you know what it's going to be? The sun function is going to be messing it up. That's why. It's going to be making a 0 basically. Right, we'll make a moon one. So that's true though. The radiance of a moon, I don't know, maybe 32. Try that out. So that's how big it is, I think. Yeah, how big it is basically. Now, I don't know if that's really going to fix it, but let's give it a go. Negative sun direction, that should be showing. Oh, perfect. There we go, we got something. So here's a little moon. We could obviously texture it to make it. But yeah, so let's put it inside this if statement so it only happens above ground. So now it doesn't happen below ground. Good, good, good. So now what we need is stars and stuff like this. So, right, so with the moon, it looks like it's probably the size of the sun. Yeah, I think you can bring it down a bit, make it a bit smaller. Although they do actually no, they're about the same size, aren't they, in the sky? I think. Yeah, because we get eclipses, right? Because that's because the moon is a certain distance from the Earth. That makes sense. So that's cool. They can stay the same size. That's great. So produces like this white light. We don't really see it on the balls, but that's probably because we're at the back side of the balls, aren't we? Right now, so they're not really illuminating the balls, which is interesting. Could we rotate the camera to see why? I think I broke it. Okay. Right, so there's the moon. And it's not really illuminating the balls. It's a shame. So, oh yeah, that's because we need another directional light in the scene. So for that, we would need... So in the scene shade, right, there is a sun direction somewhere. Hang on a minute. Lighting, sun radiant sun direction. This is it. So the sun direction will do that, but negate it. Then the moon radiance, I think we can just return, 32 maybe. Something like that, just a bit weaker. Well, it's got to be weaker, right? Then that would be cool. So we'll add another light, directional light source, which will be in the material shading. And then in the sky shading, this will be sky radiance. Sorry, moon radiance. Get. I don't know why we need the direction passed in. So moon. Yeah, we need it because it needs to be swizzled. So dot xzy. Sun direction get dot xzy. So I wonder if we need to change something here. Yeah, because I won't probably mess around with that. But there we go. Right, so now the material balls have got some light. The moonlight. It is bright though, don't you think? But that's because we ain't got the stars in there as well. We could do that. So if we made that 8, isn't the exposure just going to adjust anyway? No, it obviously is changing, yeah. So maybe 8 is fine. Radiance of 8. Cool. So at least there's something there now. So should we put some stars in the sky next? So when we put stars in the sky, they should be able to get luminance from those as well. Via the ambient. And the reflection and the reflected radiance as well, we should be able to get it. I think. Not necessarily because it's a perfect mirror. Hey Perry. Yeah, going good, thanks. Yeah, we just got the sky rendering working in budget now in terms of performance, which is cool. And we're just working on like a nighttime. So yeah, it's been going pretty good. So we've been I'm just trying to get a moon in the sky basically. Oh. It's not very good there. There's a moon in the daytime. But yeah, so basically the sky gets rendered over a series of frames, so when we change the time of day, it will take a few frames for everything to catch up. But we'll be changing it very slowly anyway, so it doesn't really matter that much. But every stage in the sky rendering, like the rendering the sky map, happens in 4 separate stages, and then rendering the irradiance map and the reflection map. Those take many frames to do. But within a second, the whole sky map gets updated now, and it takes a millisecond per frame at most. That's what we've been working on lately. But we're working on material shading as well. I've just come back to fix up the sky. So we've got this sort of like PBR shading now, but we need to work on procedural materials. So these will be done in pure shader code inside in a compute shader. We'll be basically making like a wood material and some other ones like some metal material or whatever, right? And those will be done in pure shader code rather than reading from texture files. Basically, that's going to be the plan, and we'll be working on that after we've done this night rendering, basically the night sky rendering. Yeah, it's coming along pretty good. So I guess the radiance for the so we made the if it was under the I see. Awesome. Yes, so that moon's now not reflecting at the bottom now. It's cool. Sweet. Getting there. Yeah, it's gonna be pretty interesting. After material shading is like so we're doing material shading next before we do like making the mesh shading, so the mesh rendering code, because the procedure materials is quite risky and we want to make sure it fits within some kind of performance budget, right? A full screen worth of meshes, like basic meshes like these spheres on the screen, what's the performance of procedural shading, because we're kind of dependent on procedural material shading, because we want to be doing sign distance fields, right? And well, not sign distance fields at a runtime, maybe, but they'll be compiled out into meshes. But we still need to have a way to texture a surface which doesn't have texture coordinates. So we'll be using like a 3D local space coordinate to texture them, basically. Maybe a custom one you can draw on it, but that'd be the basic idea. So everything needs to be done procedurally. Yeah, we've got to be right. So basically this one allows you to do taking a 3D position and make some stars. So let's just throw this in and just see, just start working with it. So we'll call it let's just start with this. Let's get some noise. So the way it basically works, so call it stars, I guess. Vec 3. So Vec 3 direction. Okay, so let's see how this works. So you get your direction. It's just doing some 3D noise basically. And then there's some threshold. And then there's a time-based flickering if we wanted that. We could do that. So we have G time. And then we could probably color it as well. So, didn't someone do a color version of this to see what that looks like? Oh, it's using like a temperature thing. It looks a bit too, yeah, anyways. This is output. Stars. Intensity. Now we need to put the stars in, so that would just be Eve above the ground. Vec 3 stars color. Ray direction. And no. Can we try? 1 is probably a bit too high. Let's do 0.1. Right, I'm not seeing any change, meaning we've probably messed something up in the build script. Oh, there we go. Wow, that's quite cool, isn't it? Although the projection feels off. That looks way better than it looked on that image. Terry, is that me? No. Nope. Yeah, poor guy. Yeah, he's definitely wrestling some demons, Terry Davison. He was a pretty good programmer. I hope he was actually saves Christian though. It didn't seem like I wasn't really a Christian back when I knew of Terry Davis. I didn't know if he'd really actually given his life to Christ, but he suffered from lots of stuff, demons and things. You know, poor guy. The projection feels a little bit off, not gonna lie. Yeah, he was yeah, he was entertaining and he obviously knew lots of stuff. I think this is okay because of the yeah, it doesn't really look like that great. I think it's a bit pixelated. Um there's another one we can look at. This is sort of Nebula in space. It sort of does there's like a diamond look to it. So it's kind of like a bit of like an FFT kind of bloom thing, which is kind of cool. So it takes this sort of like diamond thing, and the issue is, we got a 3D. So meta diamond. So if you get rid of that, it's just going to be a square block, isn't it? Okay. Um. Oh right, star color times by diamond. Right, star pulse size. So. Oh, okay. I see what that's doing. It's quite basic, isn't it? Wait. What's R? Okay. Pretty cool. All right. So we could. Right, it's doing cells and stuff like a grid. Obviously, a grid for us. It kind of looks alright though. Hey there, Vartan. It's just a custom text stack written in C. So C, and then GLSL for shaders, and Vulkan for the graphics API. That's about it. It's all custom, everything else ready basically. I got some single header libraries in there somewhere. Yeah, I've mostly just worked with PBR, but these days people would do PBR but still do like a stylized game, if you get what I mean, because yeah, you know, these days the sort of the thing is you want that sort of like realistic lighting kind of, because when a game has realistic lighting it just looks better. A bit like imagine if you have like, you saw what happens when you got the game like with basically no graphics, which was Minecraft, right? 16 by 16 pixel blocks of like 1 meter size in world, and you put realistic lighting into that, and it basically like looks really nice. And it kind of looks kind of realistic as well. And the low resolution kind of, if the textures kind of just gets you don't really notice them as much. But yeah, but I haven't worked on anything where it's like toon shaded or anything like that, where it's a bit different. Yeah, you can still have like you don't have to go for realism if you just have a realistic looking lighting. Nice. Yeah, what dependencies do I use? Good question. What do I use? Third party, so LZ4, STB, and yeah, that's it basically. I got my custom maths library. That's about it. Nothing special. Yeah, it's all from scratch. So yeah, we could just live with that sky, right? At least it's something. I'm not seeing anything twinkle though. Maybe we don't need twinkle. It kind of doesn't look that great though. It kind of doesn't look that great. So I wonder if you could take it's just a noise basically. It's that's a bit better. When it gets a bit too bright, you can kind of start seeing the noise. This one does it in cell grids, but the problem is we've got a 3D vector. So we could turn that into like polar coordinates, but then you'll get a higher frequency near the top. So you would get, but that could also be accounted for via some, based on the y axis basically. So you could probably do some sort of like gridded you could probably do some sort of like cell based thing as well. So XY. But then, yeah, this is another approach you could take. Let's give it a go. So we just want these ones. So we want to try nebula sky star color. Lovely. Lovely. Now I reckon do you want to get like a UV? So there's a function I have somewhere where I think it's like spherical. From spherical coordinates to Cartesian. You only go the other way around, right? So we're gonna go the other way around. I think that'd be arc cosine, wouldn't it, and all that. Let me fish that out. I have it somewhere. So I'll get to GI for my engine one of these days. Any suggestions for GI technique to start with? SSGI seems okay for starters. Not sure I want to try RT before I even know what I'm doing. Yeah, so screen space would be a lot easier to do. It's very simple, isn't it? I've heard that if you write a path tracer, it's very simple in terms of code. It's just really unoptimized, and you need to have a way which would somehow sample the scene based on array, right? You'd need like an acceleration structure like a BVH or something to make it at least bearable. But yeah, I think what people typically do is they write a really stupid simple path tracer that is slow, but at least gives you realistic results and the code is somewhat simple. But you will need some ray tracing acceleration structure like a BVH on your scene to make that kind of work at a bearable speed, right? So you're not brute forcing every triangle or something dumb like that. After that, I think the one that people typically use is when you want to implement the full thing is DZGI. Like this is what people typically use. It's just a bunch of probes, a grid of probes, and it has a system in it to capture if your probe is near a wall and basically rejects those. It'd stop leaking diffuse irradiance, wouldn't it be? It would be yeah, through walls basically. It's diffused irradiance through walls. I'm not sure if it do how you use specular then. I guess you do reflection probes for that. Yeah, be reflection probes probably. No, I'm sure you can do specular with DDGI. You must be able to. Anyways. I haven't reached PBR yet in my journey, but I've heard of non-PBR models are just dumbed down. Simplified version of the rendering equation. Yeah. Yeah, so you've got like the yeah. Yeah, that's basically what it is, right? So scene shade. So for instance, ambient light, we're getting that from this sky radiance image, and that does the back side of the ball of these balls here. But we can't really see it because the night sky is a bit dark, right? But typically what they would do in the old days, here we go, let's fix that up a bit. So if we turn off the ambient now, you'll see these just become black, right? So what they'll typically do in the old days is rather than have some sort of like physically based solution where I've baked it down into a texture and then just retrieved it. Right, it says physically based one is taking like a hemisphere of a, like, if I shoot a ray at this ball and I get the normal of the surface, I've got a hemisphere of light coming from the environment map around me. And I've captured that into a texture and I just basically read back the result, make it quick. But what they would typically do is make the ambient radiance just some sort of like fixed color. So they would just do something like, oh, let's just say in the scene there's a 0.1 amount of light just around, and they would basically just do that, right? Have some fixed thing. That's the example for ambient radiance. You probably wouldn't have reflected stuff. Maybe it just depends on the game. And then the lighting. So doing PBR lighting, it requires like a diffuse model, like this Oronaya thing, and then the Fresnel and the specular. Yeah, you probably just do, what was it? What was the simplified model? That was probably the Lambert. Yeah, it was Lambert diffuse, so it'd be far simpler than that. And then it would be a very simpler specular model, which doesn't do much. So this is all the PBR stuff. It fits on a page of code. It's not that big. But it would just be more simplified version of this, which doesn't try to emulate the microfacet nature of a surface, basically. Yeah, just a dumb color, exactly. Just addition. Yeah, the Phong model, that's it. That's PBR without GI and environment map. And environment map, right? Yeah, so it's without GI and with an environment map. Yes. Yep. So we're looking for the spherical. Look around in the old code for a minute. Hang on a minute. Ah, here are my boys. Right, GPVK. Yeah, so there's color spaces. Hmm. I don't know. Yeah, it is a little bit to understand, but Learn OpenGL does a good thing of breaking down the theory and that. And there's plenty of like videos on YouTube these days. It's not too bad. There's basically like a normal distribution function which sorts out this sort of specular highlight. There's like a shadowing function which accounts for the amount of pixel, like it's all about probability of the amount of rays within a surface that the pixel is covering. So say if your pixel covers this whole area here and it's a very rough surface or whatever, you're sort of you're saying what's the percentage of light that hits this surface, how much of it will go towards the camera, that sort of thing. That's all it's doing. And it helps you get like, you know, that's all this stuff is basically doing. And then there's Fresnel, which basically just gets the border of the thing. Right, it's the normal and the view direction and doing a dot product sort of thing. It's not too bad. It's quite simple, really. But yeah, it's just layers of simple, which makes complexity, doesn't it? That's kind of the problem. You don't have ATAN 2 in GLSL. I think that's the thing, isn't it? Let's find out. Oh, I think we do. Rightio. Beautiful. So what we can do is go to Sky Shade and we want to do UV is equal to from spherical coordinates, I think it's called. So, hang on a minute. You've got, no, 2 spherical coordinates. Yep, so a normalized vector is basically a position in normalized space, right? And then we drop the z, and we just use xy. Great. Your name is great. Function does not return a value. Oh. Whoopsie. Right. That's sort of working. Although it's kind of... Yeah, I'm not sure what's going on there. Is it not normalized? Yeah, it is. Let's convert it from -1 to 1, 0 to 1. No. Oh. You know what? We're probably doing... So we could just render the UV out. Interesting. Don't know, I think that looks correct. Yeah. Right, I think I see what's going on. We probably want to do a dot xzy. That's what you want, I think. Although that looks weird. Let's restore back the star color. Right, so that's kind of looking better. Although it's not. Yeah, we saw the UV. No, so I'm not doing the ellipsoid as a base building block anymore because it's not really going to work well with the new direction that I'm going in. It's not going to artistically. It's just not going to make sense. Uh, you know, but yeah. So we're going to be using meshes now, but we're going to be trying something a bit different still. The meshes will be made out of sign distance field shapes. So there'll still be an editor within the engine to make models and make it easier to make things rather than having to use 3D software and texture. It'll be you put shapes down and you can paint them probably with a material, procedural material, and then it will to render it, it's going to use surface nets to make a quick mesh, and then it will chuck out to Mesh Optimizer on disk, and that will make a full continuous LOD clusters and vertices and indices, and then we'll take that and then probably use mesh shaders to render it, because mesh shaders are they're the thing to use basically for that. So we'll be doing that after the material shading stuff works out fine. We'll be doing that. That's the plan. I don't understand. Yeah. Yeah, it's not necessarily super new. Like, yeah, I guess it's like 3060, NVIDIA 3060 and AMD RX 7600 onwards. So it's not super new. They've been out for a good while. Right, I'll take a quick break. Let me be right back. All right, welcome back. So, Cartesian. Yes, it's two spherical coordinates. That means it's going all the way around. Yeah, why does it go back to 0 so quickly in that? It's super weird. It's strange. Oh, it's in radians, isn't it? Is that why? Yeah, it's in pies or whatever. Right, I think. Am I right by saying that? Because pi theta and 2, so arc cosine, what's that value? What does that get you again? So that's the opposite of cosine. That gives you negative pi to pi, doesn't it? Oh, 0 to pi. Yeah, so there's your problem. So you divide pi Hang on. Wait, pi is the y. Then a tan 2 minus pi and pi. So a tan so plus vec2 pi 0 should do it. I don't know why, but for some reason RTX cars invoke thing of new to me. Right. You just upgraded, fair play. Yeah, I typically don't get new hardware either, to be honest. I just keep the machine going as long as I can. And I typically buy older stuff, like maybe 2 or 3 years older. All right, 2 seconds, be right back. Be right back. Right, sorry about that. Yeah, my son just wanted to go to the loo. You gotta have had his bed, bless him. Right. Yes, we're still working out these silly coordinates, which is most of graphics programming, I guess. So, yeah, we want to say like a tan 2. What's the range of that? Is it minus pi to pi, right? Oh, minus pi to pi. Double check that. So, your x is going to be minus pi to pi. Your arc cosine is going to be 0 to pi. And we want to try and produce value which is 0 to 1. So you add pi, and let's just divide pi. Divide by 2 pi, then pi. Right? Simple enough. No. Save me a bit kind of time when prices start increasing. Yeah. Yeah, it wasn't a good time to build recently, is it? Nice. That's really cool. You managed it just in time. Awesome. Nice. Right. So, oh, so it seems like in the negative coordinates, it's got some problems basically, but the rest is kind of fine. So the negative space, there's like 1/4. It does this for some reason. So what could that be? Um, the negative. So we could print. No, we can't print. We can, but it's a bit fiddly. So is it really like a negative value or something? It can't be. It's still got a similar thing. So the negative space. Can we ABS it a bit? No, there's no negative values because ah, no. Yeah, maybe I just switched it around the wrong way. No. These are the poles, aren't they? Surely this is going to look horrible. Yeah, I don't see any stars. Huh. Alright, what's the UV? Times 0.1 times time. Interesting. Right, so it ends up having more of a squished UV anyway. Maybe we'll scale it up a bit. Okay. You're sort of seeing the grid shape though. Yeah. So compared to the other one, we still got to obviously. So this is like a noise texture basically, in a sense. This one instead is noise. Wait, where's the noise going? There's no noise. So it's it's a hash, right? So noise, and it does this kind of like a cell-based thing with noise. And when they line up with this 3x3 grid that you do, right? Let's see. Right. But yeah, I wonder what's still though. I think I've got the UV a bit messed up though. That's why it's looking so bad. Let's see what we can do to fix that. Right, so it goes from green. Because red would be up top, wouldn't it? I wonder if you flip. That's going to cause any. The direction is just ray direction. So it's just, 0 to 1. Sorry, -1 to 1 on each axis. So even though that's spherical coordinates, it should. So minus pi to pi. And then right, so let's hard code this a bit. So we output -1. What does that look like? But it's not. So it's not outputting any minus numbers though, but it should be right because it's got minus pi. The a tan 2. It should be outputting minus pi, but it's not. So we had a direction of 1, 0, 0. You just get solid green, right? Then Alright, see you later, Perry Perry. Good to see you. Have a good night. Ah. Maybe this function's wrong. So we want to basically have a GLSL function which goes from Cartesian to spherical. That's what we want. So length, that's what that is, right? A square root dot product with itself, squared magnitude square root. That's R. We put R and Z, but that's fine. Theta. Then if so your radius would have been 1 anyway. So it would have been y divided by a cosine right Cartesian to UV. Interesting. Yeah, maybe we'll try this one out. Let's just get that. Because it's too much fiddle otherwise. Hmm? Right, it's crashing the program. Okay, let's try that out. It needs to rebuild the... Okay, I think that looks better. Yeah, that's good. So it's going a smooth gradient all the way around. That's actually what we wanted, I think. So with that, we can do this multiply by 55 or whatever and get... Oh, that's a bit bright. Right, there we go. So we're getting some kind of sky now. But Yeah, that's better. Although you can sort of see the grid. Yeah, you can sort of see the grid. I wonder... Floor UV. I wonder... It's like you've changed this stuff. Yeah, so you did like a wider kernel. You can still kind of see the grid though, which sucks. And that's because if a star is off the grid, yeah, it's not. I wonder why that's happening. So I think it's because... So you get your XY, so you offset from the grid, so you floor the UV. Right, so it'll be from 0 to 55, right? So you floor it to a 55 grid place, right? So then you're hashing the cell. There's like a 0 to 55 value kind of thing. And producing, and then adding it to the cell. The hash will get you a value from... Yeah, so then you're seeing how far the star position differs from UV basically, and your star size. Yeah, so basically there's like an offset going on. You're calculating some offset from the grid, right? Because it would just be a grid like that otherwise, right? Then you're just computing an offset. So you don't really see seams like that, right? Then star size. So I think the problem is the offset is larger than 1. So it will go to the edges of the boxes kind of thing. So if we add that, they're going to go too far off, right? And if we add nothing, yeah, so we take away 1.5, they're too far as well. So you do kind of want a 0.5, I guess. What is Yes, I think the problem is the star size is greater than 1. Oh, that's a bit better. It's moving too quickly. Okay, so we are still seeing this sort of grid here though. I think the offset is just too much, you know? So I'm not sure what the offset produces. Well, it's fract, right? So fract gives you a fraction from 0 to 1, right? So yeah, then minus 0.5 gets, okay, so it's going from the offset is 0.5, minus 0.5 to positive 0.5. So that's kind of reasonable, but you probably want to drop it a bit. But now you can kind of see the grid, right? Because it's, yeah. That's the thing, is like the fade is too big. But yeah, it's as if you want, can we increase the intensity? Right, I see. Yeah, so it depends on how big. I think you want it to be brighter at where the diamond is. But how do you do that? Yeah, I wonder if you want to make the cell size bigger, then you have less stars basically. So let's say 128. Say 96, that's always a good number. Then, wait, the cell size isn't bigger then, isn't it? 32 then. And then you want your offset of your stars to be, so if you didn't have an offset to the cell, they should line up. Do you not see any grid? So obviously you see a grid, right? I'm wondering, so if you apply some kind of offset to these, let's say 0.5. See, I want it to be intenser by the, I kind of like the stars the way these look. But I wanted them to be more intense without making the whole thing intense. So like the center point. So you could probably square it, maybe. So Have I got a square function? I think I have. I think that's what I want. Or a square root. No, squaring. So if we square the result, and then we have some intensity, that should do it. Non-linear. Right, it's looking a bit better. So we've done this sort of like double square thing. Get rid of one square. You sort of getting more diamonds now. Right, so they're obviously in a grid still. We need to apply the offset. But I think that's better. Right, I'm liking that. Then manage shader programming. It's just a bunch of fiddling around. Right, here we go. Then we gave the balls a touch in. Not sure. So what a cluster of stars there. That kind of looks interesting. Doesn't really look realistic though, this. It kind of looks like there's like galaxies in a way. Because they're a bit too bright. That's interesting. They actually show up on the reflection map. More like that because they're bright spots, aren't they? What's the game going to be about? We've got to find out yet. Need to do lots of praying and things to figure out exactly what I want to do. But first, we've just been building the engine components. So we obviously want to set it on planet Earth. So we're building sort of a sky at the moment. We have a day, but we need a night. So there's the day, but we need a night. We're just looking at building a night right now. But yeah, we'll do some like mesh rendering of that at some point. It's just Helix code editor. Oh wow, is that a lot of stars clustered around there? That's crazy. Yeah, that is crazy actually. Super crazy. You don't even get the diamond anymore when you do the square. It's not very nice. I wonder if you can square something else. Simply praise your name. Yeah. Right. I think this works. I'm not really seeing the grid like this, which is good because I've got the square on there, I think. But we're not really getting too much of a diamond shape though. And there is a cluster of stars right there, which kind of blooms out a bit too much. Yeah. I wonder if I wonder if we punch this into a noise. Noise P. Oh, it uses hash, doesn't it? Alright. Well, we'll do PCG hash as well. Maybe that'll be better. Let's try that. Right. Yeah, it's not really helping out, is it? We want like a random offset basically, and I think it's this is not that good of a function for it. But yeah, then also this, you kind of want those diamond shaped things, but ends up revealing the grid because it kind of sucks. Yeah. Hey Kat, how's it going? Yeah, it's working on some stars right now. We have a moon. Working on some stars. This is the other one that we have. I think this is the better one. I was trying to see if I can get some sort of nice diamondy stars, but I think just in this noise texture is probably best. Uh, yeah, I think we might do this one. Bit too starry. Yeah, we could color it at some point as well. We could take that coloring that it was doing at least where it wasn't exactly white. Cool, I think we can live with that. So I wonder what we can do to get this sort of nebula looking thing. So it was doing like an FBM basically. Do a 3D fractal Brownian motion. So that's what they were doing. So it needs a noise function though, but we have a noise function. That was pretty bright, I think, or appear to be. Yeah, if you're in dark space, that's right. Hmm. I'm not sure if you I'm not sure if you're actually serious about that last comment. But yeah. No, they are usually quite bright. They can be when you're in the dark. But there are obviously some faint ones as well. Let's see if we can play around with like a nebula. So fractal Brownian motion. What's that frequency? Why is there a frequency there? Larinacrity, double frequency. That's not really a good one. Right, stop there for now. Number of octaves. So 3D noise, I've already got one. Cool. So in terms of doing a sort of a nebula thing, it was like, where's the FBM? FBM plus, okay, so a few different FBMs and then blending in. Right, so if we could take let's have a bit of a play. So let's do nebula. Nebula. So let's take the direction in. Nebula. So, see if we could play around with this. So it's basically there a T. We don't really need a time. Plus some random offset, I guess. Yep. So this is where it's feeding its an FBM into an FBM. You know, it's like I forgot what it's called now. That is called, oh, I forget the name. Oh, it's called domain warping. Domain warping, that's what it's called. Alright, let's give that a go. 100% serious, it happened. People had never seen the sky like that before. 94. Earthquake not to the power in LA, right. Only in America. Man, America. You guys, man, sometimes do the most insane and stupid stuff sometimes. It's funny. Aliens. Exactly. They're coming. Trump is talking about the aliens. You know, just be careful about it. Yeah. But seriously, though, be careful about the aliens because they're probably going to be the next. They're the thing which they're going to try and explain away God with aliens again. But no, here's the thing, right? Trump said he's going to dedicate the country to God again, but also aliens. So that's the thing you got to be careful about because it's probably the coming deception. Because here's the thing, the enemy, the devil, has to explain away why a bunch of Christians are disappearing. Right? So there's a rapture coming, you know, Jesus Christ is coming to collect us. And then we're just going to hop Potso out of here. Bye bye. Now the question is, how are the normies, right? Well, not normies, sorry, it's a bad way to put it. How is the unsaved people going to be like, oh yeah, the Christians have just gone, good riddance, right? Without being like, without it being obvious that they got taken by Jesus. So the way you can explain it away is aliens, right? So the US government announces there's aliens, and then the aliens come and take away all the mean Christians, right? All the people who stop us from advancing in science and technology, those pesky Christians. That's one way you can explain it away. And the New Age lot are all on this, by the way, because the New Age lot that believe in aliens, they like they basically believe that you have to reach this higher consciousness and stuff like that. And yeah, anyways. Oh yeah, they're trying. Yeah, that's it. They're trying to explain the Epstein files away with aliens. That's very true, because they've leaked a whole bunch of. Well, they're not leaked it. They've released the documents, right? And it's basically got a bunch of like really crazy stuff on there about like how, you know, conversations that supposedly they had with Bill Gates about how they were going to reduce the population of the world. Also talk code words for like child meat as well. Really insane stuff, and that's the stuff that we know about. Right? What about all the stuff we don't know about? Like, I honestly reckon it was the biggest, like, you know, I reckon it was a satanic cult. Lots of child sacrifice going on, unfortunately. Really wicked stuff. So if aliens start allowing us to leave, does it count as a rapture? No, because the rapture is specifically Jesus coming to collect his bride, right? But yeah, so basically, if the aliens do exist and they're real, they're probably fallen angels or demonic entities. So there's in the yeah. So it gets quite deep. But if they're real, they're probably fallen angels, like at the Bible when the angels came down and mated with humans and made giants. They're probably those species, the angels which rebelled against God, and they have technology, like because in the Bible there's plenty of technology that the angels have. So the fallen angels just want to disguise themselves and trick humanity into believing that God does not exist, right? So if they're real, they're probably fallen angels in disguise. And they could have made some, you know, they could have got some technology where they've made some subspecies and things like this. Because, yeah, there's lots of theories out there. But what if Jesus is an alien, though? See, that's the thing they want you to believe, is Jesus is the alien. That's what I believed 10 years ago. I was like, well, if aliens are real, then that means Jesus could have been faked as being an alien, right? But then I had my encounter with Jesus, and then I'm like, no, it's the other way around. And the Bible says this, Philippians 2. I guess we'll do NIV. Not really a fan. Adonai Elohim, great I am. 2:9 in it. Therefore God has also exalted him, Jesus Christ, given him the name which is above every name, so that the name of Jesus every knee should bow. Those in heaven, so that's actually in heaven, and those in the heavens, on the earth and under the earth. So if there's anything that lives under the earth, because that's the other theory, right? Is that aliens don't actually live, they have bases under the earth, in the water. You see the UFOs have been seen in the water and stuff, and also in underground bases. Yeah, it's really deep, and that's why there's a secret in the government, apparently, because supposedly the government works with them in underground bases. That's the other theory. So you have to be careful. It's a big deception if it is real. Don't believe the aliens, 100%. Nah, it's alright. We can talk about aliens. It's fine. So I only have a guideline against religious aspects in game plots, I think. Fair play. I didn't realize that. Great I am. But yeah, one thing to be aware about Trump is the following: he's becoming the globalist, the leader of the globalists. I think you got to be very careful. But no, Trump is an interesting guy. People hate his guts, and some people love him. I'm like on the fence. Like, he does some good things, does some bad things, like every human being. What you gotta realize is so people have been crying so hard, like Trump's gonna have a third presidential term. But we don't realize he's doing something worse than that. He's made the board of peace, right? So the board of peace, he's the president of that, and he's going to probably be on that until he's dead. And the board of peace is a globalist thing where a bunch of countries come together and they talk about peace amongst, all over the whole world, right? Now you take a look at this. Look at the Bible. Adonai Elohim. This is the day of the Lord, which is the tribulation. But concerning the times and the seasons, brethren, they're talking to Christians, right? So You have no need that I should write to you, for you yourselves know perfectly that the day of the Lord, so the 7-year tribulation, so comes as a thief in the night. So it comes as a thief in the night to people who are not believers. People who are believers, you should see it coming. But when they say peace and safety, that's the key word, right? Then sudden destruction comes upon them, as labor pains upon a pregnant woman, and they shall not escape. The basic idea is Christians looking out for this, right? When the world is going, peace and safety, it's going to happen. And then sudden destruction comes upon them. So there's a sense of false peace which is going to come. And that's probably the board of peace that Trump has got going at the moment. And, these things come upon as labor pains upon a pregnant woman, meaning you have them kind of show up gradually spaced out, but as it gets closer and closer to the time, they come more and more in succession to one another. So what you find out is we're probably approaching that now, maybe. And there'll be something to do with this peace and safety. But yeah, then it'll kick off the tribulation, right? Where you got the 4 horsemen of the apocalypse. Probably to avoid some offense with some unhinged ideas game designers will run with. I don't know. Yeah, I think they just don't want to, I think, alienate like a big part of their audience, maybe. I don't know. President Board of Peace will help rebuild Gaza. Could be wrong. See, that's the thing about it. Here's the globalist agenda. Ready? Digital IDs, AI smart cities. So, Trump's son-in-law, Jared Kushner, that guy has a plan to build an AI smart city in Gaza, right? Now, why do they want to do this? Well, probably so that they can track to see if there's any stuff that will go on and stop any terrorism basically in the future. So they can track everyone and track what they buy, what they sell, where they are, when and where they were. Now, what's interesting is you might be thinking, that's not a very Trump thing to do. Because don't the left want to do this? Right? And what you got to realize is no, it's a globalist thing. The whole world is going to be doing it. Like in this country where I'm now, Keir Starmer said he wants to make a digital ID where if you want to work, you have to take the digital ID, but it's optional. And by optional, he meant that if you don't work, you don't have to get it. So it's basically forcing you to get it because everyone has to work. And what you realize is the UN want to install this AI smart city stuff as well. UN 2030 agenda, digital IDs, track everyone, where they're going, what they're doing, and you'll be the vice grip of the state. It's a globalist agenda. It's real bad. The problem is it affects both the left and the right. You got to be careful. But yeah, I think Restore Britain is going to be the only way around it because they're like Brexit style, where it's like get away from the globalist, and that's the biggest problem is like we put stuff in the buckets of left and right, but it doesn't work for everything, for lots of things actually. And the biggest thing is this plays into the tribulation, because in Revelation 13 it says you have to take the mark of the beast if you want to buy or sell anything, and if you take the mark of the beast, you're damned to hell because you're worshiping the devil. There'll be a clear choice. And it fits right in to all this technology which is coming around right now. That's the biggest thing about it. Crazy. Yeah, left and right is pretty meaningless. I think like the original left meant like you're for change, and right you're for like keeping stuff basically the same. But then like that means the left could mean like absolutely anything. You know, it's always politics is, if you want to, yeah, it's not really the best area of development, I guess. It sort of works. It's an old trick, yapping about peace and also invading Canada or Greenland. Yeah, yeah. So with that, right? That's again part of the tribulation. What you gotta realize is there's a prophecy where there's gonna be 10 kingdoms in the world, and what you're seeing Trump doing right now is acquiring all those areas of the North America, and creating one of the 10 kingdoms for the tribulation, and is doing it without knowing it. That's the thing, because the Bible's predicted the future. That's the thing about it. Worry more about the UN or NATO being more globalist in nature than Border Peace. Yeah, well, yeah, Border Peace wants to work with the UN, but the UN's definitely been at it for a long time, and the WEF as well. Since the leaders of Border Peace are sovereign rulers rather than single unelected leader. Hmm. Don't you buy your seat at the Board of Peace though with money? Like, isn't it like $1 billion gets you a seat for life? In terms of left and right, okay. Yeah, AI, yeah. Yeah, exactly. What's the labels? Isn't much anymore. Still sovereign leader, but there's a single position. Right. Yeah, I haven't looked too much into it actually. I need to look into it a bit. Why did this work in the end? Nebula no matching overload. Ain't that like a... Oh. Put in the wrong section. 158. Ah. That looks sort of alright. We're getting it sort of blues and that in the sky, but it's got some issues, I guess. So we got to change. It looks nice, but kind of looks a bit odd at the top. I wonder if we can swizzle it a bit. That's alright, doesn't it? Man, I'm loving that. There's a bit of a seam on the texture, but we can ignore that seam. Adonai, Elohim, great I am. Yeah, I'm not sure why it goes black in a bit of an area though. I guess you just... it looks nice in like quite a lot of places, but then this side, not so much. But yeah, you just basically monkey around with these. So it's made it higher frequency, it's multiplied it. The sample, so the direction. That looks quite nice. I'm not sure about this though, but that's cool. I'm quite happy where that is, to be fair. Could always be better, but it's better than having nothing. Completely tweakable. So it's even there in the sort of the switching over between the night and day, because obviously it just keeps being rendered. And you can still see some stars during the day as well, which is cool. Maybe. Maybe it's not. um, but yeah, I'm happy with that. That's good. Amazing. Okay, so we're going to be streaming tomorrow at 2 p.m. GMT. And we'll be working on materials, stuff to do with materials. I'll be checking this in. So that will be the material plan. So we've done this PBR specular gloss. We want to double check that tomorrow to make sure it's all good. We've done this pre-filter sky map generation, so we had to go back to make it performant because it was like it was very expensive to do this at runtime. So I've had to do over a series of frames, but that's all good. So we want to be working on sort of like procedural material shading side of things. Ultimately, we want to build a compute shader which allows us to have some shader code in there and a switch statement to like, you know, make wood and metals and different materials in pure shader code at runtime, which is going to be, yeah, it's going to be expensive, but we're going to see if we can pull it off. So we won't be, we'll probably be reading from some noise textures, but yeah. But the reason why we're doing this is because we want to use a 3D UV rather than a 2D UV, because 2D texture mapping is going to be horrible. We want to try and just do it with a 3D UV, like a local space coordinate. Now, we probably need to think about how we're going to store these on disk and stuff like this, and I might have to mess around with the encoder system a bit. So we'll probably be going over and doing a plan and thinking about some of this stuff tomorrow's stream, and also getting started on it, which would be super cool. But yeah, the ultimate idea is to build maybe some brick, proto material, dirt, sand, copper, gold, steel, maybe a ware. I'm not sure about that. But yeah. But yeah, in the meantime, guys, there is a Discord if you can come and chat about things, if that wants to work. And there is, you know, if you want to support the channel, there's a membership via Ko-Fi, and you'll be able to get this code and run it on your local machine, and also support the channel in the meantime. But yeah, thank you for everyone who's supporting the channel at the moment. Appreciate you all. And yeah, check the schedule down below for the stream times and things like this. Right, have a good night, guys. Good to see you. and I'll hopefully see you tomorrow.